Hello everyone. So good evening. We'll wait for just 2 more minutes and then start, uh, so that if any other people want to join, then they can join in the meantime. All right, so I think there are enough people to start today's session. So welcome to the problem solving session of the course Geographic Information Systems. I am Anjana. I'm the teaching assistant for this course, which is taught by Professor Saraf from IIT Kanpur and IIT Roorkee, and I'm from IIT Kanpur. So the basic idea of this problem solving session is my plan is to recap whatever has been taught in each week, and then we'll discuss the concepts, and if you have any queries, and then we'll also discuss some problems which will help you in doing your assignment, which is given for each week. So today's session we'll be discussing, the discussion will be focused on the week one lectures, and the next week we'll be discussing the week two lectures. And one point I would like to emphasize is that we have been strictly instructed not to discuss any of the assignment questions before the submission date. So please refrain from asking anything from directly from the assignment questions. But then if you have any clarification regarding any concepts, then feel free to ask me. So without any further ado, I will share my screen, and just please let me know if you can see it. Or before that, can you guys just tell me like if you already have a background in GIS or if you're completely new to this? You can message or you can just tell me anyway. I just want to know like what background you people are coming from. Okay, so Tubaya is new to this. Okay. Anyway, I'll be like focusing on the basics, like the lectures only I'll be focusing so that it is helpful for you people also. But yeah, according to your requirement, I can bring in more information as per requirement. Yeah. Okay, then I think most of you might be new to this, or if not, it's okay, but we'll start from the basics. Okay. Okay, so I'll be sharing my screen. So just let me know if you can see it, because since it is Google Meet, I might have some difficulty in going from the shared screen and to the screen. So please let me know. Can you see this?
Yes, ma'am.
Okay, thank you. Okay, so we'll start. So as I said, we'll just touch upon all the topics that has been discussed in the week one lectures. so that it will be kind of a refresh of all the things that you have learned or you have gone through. So, if you have any queries, you can ask me. Okay. So I've changed into presentation mode. So as I said, the course is Geographic Information Systems. The instructor is Professor A.K. Saraf from IIT Roorkee, and I am Anchana. I'm a PhD scholar from IIT Kanpur. Okay. So yeah, we'll go to the week one topics. So we started with what is GIS. So anyway, like you at least know what this is, an abbreviation, and which is basically Geographic Information System, right? So, if you remember from the lecture, so Professor Saraf has said this GIS, the origin of GIS was in Canada, and then later on it expanded worldwide. And the person who sort of started it was Roger Tomlinson. That's not very important. It's just trivia. So basically, if you look at this, like you have this name, right? Geographic Information System. So I have some problem with my pen, so I'll try to do with this uh, screen itself. But yeah, if I hope it's legible to you. So we have this geographic information system, right? So we'll just break it down and we'll see that when you say geographic, okay, geography is what like there are people who are studying geography, so it's not per se related directly to geography, but rather when you say geographic, we are actually referring to the locations of places on the Earth's surface. Okay, so it's just locations, like you say latitude, longitude. I hope you're familiar with that. So that is what is this geographic is referring to rather than the geography aspect. Okay. And then when you say information system, that is basically you work with the information that is stored in the computer databases. So you have a computer, you have a lot of information in it. That plus the geographic information, all these integrated, you get the geographic information system. Now, the definition that was given was this is more technical. So, that is like it is a computer based information system which is designed to accept large volumes of spatial data derived from variety of sources and to efficiently store, retrieve, analyze, model, and display these data according to user defined specifications. Now, this is a very big definition. You don't have to go through every little thing, but the basic understanding is that you have a computer which has a lot of information, and you have a person who's telling you to specifically, give you information about something. Uh, so the user defined specification, the user requires certain information. Sometimes that person might require the say the population data of a particular region, of a district or a state. So that is user defined. So he's not asking for the data of an entire country, but rather a particular state or a particular district. So that is what the basic essence of GIS is. Okay. So, and as I said, like this manipulating of data, that is not you're not tampering with the data, but rather you're just changing the data from one format to the other. Like for example, if you have a analog data, you kind of change it to a digital data. Or if you have rows and columns, you change the row into column into row. Like if you are familiar with Excel, you know that, right? You have a lot of rows and columns and you just transpose it or you change it. So that is just a basic gist of what GIS is. And so GIS can essentially transform data into information. Data is just numbers. You have a lot of numbers, but what will you do with the numbers? It's pointless, right? Only when that number gives you some kind of information, then only it is going to help you out. So that is why I was saying, or the professor was saying, like user defined specifications. Always it is depending on the user. So if the user only requires a little bit of data or information, then you use the data accordingly. And if they need a lot of information, then you might have to use a lot of data for that. So then Professor also talked about the GNSS, and I also saw a query in the forum, so that's why I kept this here. So the GNSS is the Global Navigation Satellite System. So what is like you might be familiar with the GPS. Like everybody is familiar with the GPS because you have the smartphone with you, right? So if you have to go, if you've gone to an entirely new place and you want to uh, explore a particular, let's say, a tourist place, and you want to see a particular site, and you don't know the way to it, so you put all the information on Google Map and then you go, right? The Google Map gives you the information. So from where does it give you the information? So that is basically the data which is obtained from the satellites. So how does the global navigation satellite system work? So the global navigation satellite system is basically you have satellites in space, right? India has sent a lot of satellites. Different countries have their own set of satellites. So this satellites in space, they are orbiting the Earth, just like how our moon is going about our Earth. Similarly, the satellites are also moving around our Earth, and it is constantly sending signals to Earth. It's not like it's just going about. At the same time, it is giving us signals also. There are different kind of satellites. We have weather satellites, we have communication satellites, all kind of. So like whatever is our requirement, that kind of data can be transmitted by the satellites. So this data is received on the ground by receivers like our phone, or you have other GPS tracking devices. Okay. So what happens is, by picking up signals from at least, let's say, 4 satellites, the device can calculate your position. And then with the data which is already there in the system and everything, then it kind of directs you how you can go to the location that you want to go. So that is how the GNSS works. Now, the example of GNSS is GPS, which you are already familiar with, which is the Global Positioning System. This is the most well-known example of GNSS, and it was developed by United States. Then we have GLONASS. I'm not reading it out entirely; it's a little difficult. Anyway, that is Russia's GNSS system. Then we have Galileo, which is Europe's GNSS system. Then Beidou, which is China's GNSS system. Then we have NAVIC, earlier India's regional, that is regional, not global, regional navigation system. So that is NAVIC right now for India. Earlier it was IRNSS. Okay. And then for Japan, it is QZSS. So these are just examples that if you are interested, you can just see how all these things works. So that is regarding the examples. And then where is this GNSS used? So as I said, it can be used for navigation, for cars, for planes, for ships. So like in planes also they get information, right? If you have traveled in a airplane, you sometimes in a long distance airplane they show like where you are right now, and similar to how you do it while you're traveling in a car. So in cars it shows, in planes it shows, even in ships it shows. That is for navigation purpose, like how you can reach one place from another. Then you can find locations, just as I said right now. Then for agriculture, like for a more precision farming and all, for that purpose you can do disaster management. You can do like recently in Los Angeles there was a fire incident, okay, a forest fire incident, and during that time like it's not very easy to access the interior parts, right? Like so for rescue and rehabilitation purpose and all those things, this navigation system really helps. Like you don't have to go there in person, but rather you can figure it out, make a strategy and do whatever is necessary. Then for scientific research, so those of you who are in geology field, you might know that we have this tectonic plates which move at a very slow rate, right? So it's like centimeter per year or something like that, very less. So effectively you are not going to see how much it has moved. But if you have GPS stations at every they have installed GPS stations at these plate boundaries, so you can actually see how far these plates have moved away from each other or towards each other, whatever it is. So for scientific research also, the global navigation systems can be used. So GNSS, if in what do you say? Like it's like a worldwide positioning system that helps you know exactly where you are anytime, anywhere. So it's a very convenient discovery, you can say. So, and then this difference, like you might be familiar with all these terms, like GNSS we just discussed, GIS I said, remote sensing also, like if you have, you might have a little bit of knowledge. So what exactly are all these three doing? So GNSS will give you the location data, as I said, XY coordinate or the lat long data. The remote sensing will provide you the imagery, the satellite imagery and observations. The GIS will combine all these things, the location data, the imagery, the observations, all those things, and visualize the information for better decision making. If you are, this is what I was talking about, the forest fire scenario. What will happen is the remote sensing, the satellites will capture the images and show us the areas which are affected by the fire. So the image is captured. GNSS will record the exact location of burned areas or set up monitoring stations. Like the field researchers can do that. And GIS will combine this satellite data, the GNSS data, and other information like in which direction the wind is moving and all those things. It will combine that and will let you know how the fire has spread and like, or if there is a possibility of further spread of fire, and then also for predicting future risk. So this is kind of like modeling. Like those of you are familiar with data modeling. So this is kind of like that. So this was an example which the Professor Saraf said about GIS without computers. So the all these examples that I'm giving, that is like purely computer data, all those things, right? But in 1854, when there was a London cholera epidemic, at the time the computers were not so prevalent. Even then, GIS was helpful in the sense that it helped to find the water pump or tube well which was providing the contaminated water. So basically, if you take a look at this, so you can see this plus sign, which is like marked by red, is basically where all the cholera death has taken place, and these round blue ones are where the water pumps are. So if you're just staying in that place and you have a number of water pumps or tube wells, you don't know exactly which which tube well is causing the problem. But if you look at a wholesome approach, like you look at it from an aerial view kind of thing. So this is basically what you're doing is you have the street map. So these lines are the street map. Then you have the water pump locations. Then you have the cholera death. So what they did was they looked at this and they could see that all these, death that was concentrated especially around the center tube well. So as a result, they understood that okay, this is what is causing the problem and not these ones which are away from it. So that is how they determined it and they could take necessary actions. So this was when you didn't have these computers to do all the data analysis. This is like purely you are using the layers one upon the other and then determining the answer to your question. So layers is basically like if you just have the street map, that is one layer, then the cholera affected region is another layer, and the water pump or tube well locations is yet another layer. So you will be more familiar with these layer concept when you are actually doing all these things practically in a GIS software, then you will understand better. So this is what GIS does. It can represent a simplified world. So you have this street data that I just said. So this is just basically some lines. So that is like if you just need to know where a street is going, then that is fine. Only this data is required. But then if you need building data, so then you combine that. Then you need the vegetation data, you combine that. Then you integrate all these things so you get a consolidated data, a simplified world. So sometimes, like when you're planning a city or something, instead of directly going and building the entire thing, you can actually, use GIS to see how things are going to work out. So in that sense, GIS will give you a very simplified world. So these are the stages in a GIS project. So when you get a GIS project, so what they do is first they will define the problem. Like what is your requirement? So for example, we had the recent pandemic of COVID, right? So you might know about containment zones and all those things, like where the COVID is the most prevalent. That area was contained. People were not allowed to go out, come in. So how did they mark the boundary? Like how did they know that okay, this much of area needs to be contained? So like that was the problem that was defined. They needed to know how much area was affected by COVID. Then they need what? They need the software and the hardware. Okay, software and hardware is basically software is GIS softwares, and hardware is like the computer and processor, all those things. Then you gather all these data, you clean the data, like you have a hell lot of data. You don't need all those things, right? So you clean the data, you do the analysis as per your requirement, and then you present the interpret and present the results. This is what happens during a GIS project. Now it's not just about this COVID thing. Anything can be like uh, you know uh, like electrical engineers use this thing. So it's like that's what I'm saying, like user defined. It's completely user defined. Now we'll discuss the components of GIS. Okay, so the components of GIS is basically like we have five major components. Like there are materials in which they discuss more, but then these are the five essential components of GIS. So we have the hardware, which I was talking about. Uh, just a moment. Yeah. So we have the hardware. So that is like the desktop, the computer, which you have a screen. Then we have a mouse, we have a keyboard, we have a processor, hard disk, etc. So all those things come under the hardware part. Okay, so that is one component of GIS. Then we have the software part. So software can be any kind of GIS softwares, like ArcGIS is there. The professor has also mentioned that. Then we have an open source GIS software, which is the QGIS. Okay, so that is regarding software. Then we have data. Data can be of different types. We'll discuss that. But then on a more general term, we'll be discussing about spatial data and non-spatial data. Then we have people, obviously, like who do the work and who are also the users. So that is there. Then we define the methods and procedures. So that is how this entire thing combines to give you the output or results. So this analogy which sir has also mentioned is like it's like you have a toolbox, but then you need to know how to use it, and then you need to know what the requirement is. So according to the requirement only you are going to build or do something, right? So GIS expert can suggest the kind of data which is required for preparing a design or map according to the user specifications. So if you want to, let's say, build a cupboard, okay, in your home, so you have to give the specifications to the person who is making it, right? You have to tell him like, I need this much of, you know, uh, space inside that cupboard. I need this much separation in the cupboard. I need this height, all those things. So that is like user specifications. Okay, so GIS expert, that is like he or she can give the suggestions like these data is available. We can do all these things. But what do you want? What is your requirement? So according to that, you get the output. So, and data, like we'll discuss that in detail, but then just to touch upon the topic, basically we have the, uh, I'm sorry, my pen is not working. That is why it's not very smooth, but yeah. Okay, I let it be. Data can be spatial data or it can be non-spatial data. So spatial data is like, for example, if you say, uh, if you know a region where you have earthquake, okay, so we know that every earthquake has an epicenter or where it is originating, right? So that location of that epicenter of the earthquake, uh, I hope you know all like this example. That's why I'm just saying it. So you have epicenter of the earthquake, and you need to locate it. So that location is basically your spatial data. You are getting the lat long or that XY coordinates you're getting. So that is the spatial data. But the non-spatial data of that particular earthquake or the attribute data of that earthquake is the its magnitude, at what depth it is there, and all those things, like how much it has affected. Those things come under the non-spatial data. The spatial data is the location from where it has originated. So that is how you differentiate. Like I'm giving you an example of how to differentiate between spatial data and non-spatial data. So now we'll just discuss the components of GIS a little in detail. Like I just touched upon it, but then yeah. So hardware is basically the computer on which the GIS operates. So it can range from the big computers in like very big laboratories or workstations to the smartphone that you have in your hand. So that is the hardware. Like your hand is also not hand. Your smartphone is also a sort of contains a simplified GIS in it. So that is basically the Google map that you use, the location and all those things. Okay. Then you have the software, which I said. You have the GIS software, which provides the functions and tools which is needed to store, analyze, and display geographic information. You guys can stop me at any point if you have any queries. I don't want this to be a monotonous discussion, so please. Uh, okay. So the GIS software will have multiple functions, like you can, according to your specifications, you can use it. And like those of you who are new to this entire thing, yeah, I would suggest that if you don't have access to ArcGIS, which I think that requires license agreement, so rather you can download the QGIS to explore. Like they have these sample things in it, so you can actually get a hands-on experience. It's very interesting. Then key software components are the tools for the input and manipulation of the geographic information. Like you have a geographic information, you have XY data, but then how to, you know, change it according to your requirement. So for that, you need certain tools. You have several tools like, merge to separate the data, all those things. That's what I was saying. Like if you download the software, then you can see like what all tools are available in the GIS toolbox. So it's very interesting. Then you have a database management system, like it contains all the data, not every data, but then yeah, to some extent the data that you require. Then tools that support the geographic query analysis and visualization, like you have at times you'll have to georeference your data if it's just an image. So such things. Then the graphical user interface for easy access to tools, because this is like earlier everything, those who are experts in coding, for them it's not difficult, but then people who don't know coding as much, then the user interface should be very easily accessible. So that graphical user interface is available in these softwares for easy access to the tools. Otherwise you will have to do all kind of coding and it might not be that easy for each and every person. Then, of course, the most important thing, that is data. That is like, although GIS requires all the five components and like it's equally important, but then at the same time, data has a little bit of more importance, because without that, nothing can be done, right? So that's what I was saying, spatial data and non-spatial data. So a GIS, what it does is it will integrate the spatial data with other data resources and can even use a database management system used by most organizations to organize, maintain their data, and to manage spatial data. That's a pretty long definition, but then the essence is Just that you have the spatial data, that is the XY coordinate is there, so that you can integrate with other things. Like for example, let's say you have you want to know the uh, mm, let's say, what example can I say? The road network in a particular state or particular district. So first you need to get the location, right? So you have the spatial data. Then you have to uh, use the data resources which contain the road network data. You integrate both of this, then you will find the information as per your requirement. So that is what GIS does. It simplifies things for you. Because see, all these things that I'm saying, like uh, y- you it's actually available all around you, but then the problem is that uh, too much of data all around you, you don't know how to bring it down to the necessary information that you want, right? So for that purpose only, you need something like GIS. It will simplify everything for you, because otherwise it's like uh, for example, you need to know the hospitals in your area. Okay, so you need to have a record of all the hospitals in the area. If you plan to do it on your own, you will have to, it's kind of like a time consuming process. You will have to go from each place to track the thing. So that's like very difficult, right? So for that purpose, if you have all these informations already available, you have the location information, then you can basically integrate everything, and then that is like GIS does that for you. Then, of course, people they manage the system, and at the same time, the users are also important who give you the requirements. This I've already touched upon. So, yeah. So, a successful GIS operates according to a well defined plan and business rules, which are the models and operating practices unique to each organization. So, it's like, as I said, like you have a database management system, like you have a ton of data, you have a lot of data with you, and it's not necessary that you need all the data at one particular time. So it's like you need a plan. What do you actually need? How much of information do you need? So integrating all that, uh, you have to plan and then integrate and then get the output. So well designed plan is very much required in case of a GIS uh, process. So, as I said, we'll discuss about the GIS data. So, there are basically two categories. Okay. So, as I said, we have the spatial data and the non-spatial data. So, spatial data is basically, as the name suggests, something related to space or place, right? So, that is the location. So, where is it? Where do you see this thing? So, that question, the answer to that question is your spatial data. Where is it? And then non-spatial data or the thematic data is basically what is it? Okay. Uh, so the spatial data, it can be categorized into vector data, raster data, and tin data. These things we'll discuss in details in the upcoming you know lectures. But then I'm just telling you about the categories. So raster data is mainly based on grids and pixels. Like if you capture, you might be familiar with pixels at least, right? If you have a smartphone, so you know how much pixels worth of photo it is capturing. So raster data is basically about the grids or pixels. So example is the satellite imagery, the image that you get. Whereas vector data, you don't get such beautiful images, but rather you have points, lines, and polygons, lines or polylines, whatever it is. But you have a very simplified version That is point. Uh, you have a point, then you have a line, then you have a polygon. Okay. So that is how vector data is represented. Raster data is more or less in terms of grids or pixels. Then you have the attribute data or the non-spatial data, which is basically tables, charts, or text. So that you don't actually like that is kind of like additional information to the location information. So example of that is a school, which is the spatial data, like where that school is located. It can have non-spatial attributes like the number of students in the school, number of girl students in the school, number of teachers in the school. So that is like attributes. That is not a part of the spatial data. So that is regarded as non-spatial data. Then comes the vector data. We'll discuss that in detail today. So that is like it describes geographic objects using points, lines, and polygons. Just a moment. I'll try to rectify my pen so that I can write better. I'll just see. Just give me 2 minutes. I'm not able to do it. I'm really sorry. I'll rectify it by the next session. Anyway, today we'll continue like this. Okay, so vector data, it describes the geographic objects using points, lines, and polygons. So what do you mean by that? Okay, so point is whatever is represented here, the point features. So you can see here, right? So these are points. So that is like it represents a single location on a map. I'll show this in Google Earth so you'll understand it better. And this point is regarded as a zero dimensional entity because it's like it only gives you x, y, nothing more. So it is regarded as a zero dimensional entity. And then it is defined, as I said, xy coordinates, latitude or longitude. So example is like if you are just looking at one tree, a bus stop or a city, so that's like one point. So that's nothing more than that. Then comes the lines. So that is like linear features, which is connecting multiple points. So you have the example as roads, rivers, or pipelines. That is line features. Okay. So in a map, you see these. See, in reality, a road has this much of width, maybe it has a thickness or whatever it is. But when you have an aerial representation, you see it as a line only. Similarly for rivers or pipelines, they have some certain width for them, but then that is like in on the ground. But then when you look at it from a height, like in a satellite data or what, from a great distance, then you just see them as lines. So that's why they are called as linear features. So vector data can also be represented as lines. Then another thing is polygons. That is represent areas enclosed by connected lines. That is given here. So that is lake. A lake cannot be represented by point, like it can be represented by point, but then it can also be represented by a polygon in a much closer scale, okay, or forest boundaries. So I'll just, for the benefit of understanding this better, so I'll just show it. Can you see the Google Earth? I hope it is visible to you. Okay. So if you take a look at, let's say, our country, and I'm just randomly zooming in. Okay. Yeah. So here you can see, right? Indore, Ujjain, Ahmedabad. This is like I just randomly zoomed in, so whatever came, I'm showing that. So these are all represented as points. Now, if you are from one of these places, you know that your region is not a point, it's rather a very big area, right? But because we are looking at in such a scale, so it's like represented as a point. Now, if I zoom in again, see, let me just go to a specific point, or rather, I'll okay, I'll zoom to Mumbai. Okay, so this region is represented by a point right now. Now, if I just go into this, so you can see it's not just a point, but rather you're getting more and more, uh, space in it, right? And also here you can that's regarding the point features, and here you can see the line features. See all these yellow things, they are actually roads, but then if you uh, hmm, just go a little back, so you are just seeing it as lines. Okay. And similarly, if you come to this region, let's say you just want to demarcate this area. I think this is some water body, but what else can we take? We'll take this for the time being. So this can be regarded as a polygon. Okay, so you can actually draw boundaries around it and it can be considered as a polygon. Or else something else I can show. This patch of land, I think there is a polygon feature, so I can draw it and show it to you. Okay, so I am trying to draw the boundaries of this area. So this area, if I had taken it a little back, I zoomed out, then this could have been represented by a point. But now as I zoomed in, we can see that it is an area. So we are basically doing it with a polygon. So this area is represented by a polygon. Similarly, I think line feature also I can show you. Yeah. So like this, we are connecting. So this is like polylines, okay? So similarly, this pathways can be represented by a line feature. So that is the gist of how you say vector data can be points, lines, or polygons. So back to our topic. So the vector data, in that we have the terminology that the point that you're saying, no, that single one, that can be called as a node. And when you talk about a polyline, you have a vertex that or plural vertices, or node is a point that specifies a position on a line for arcs, polylines, or and polygons. So it's like this is where the line is starting. So you have a beginning node, then, if you have seen that image I just drew in the Google Earth, also you have seen these nodes, right? There are points where it is starting, then the end point is there. So, connecting nodes are also there. So, these are connecting nodes or internodes that are in between and then where you stop it, that is the end node. So for a polygon, like when you discuss a polygon, its begin node and end node will be more or less same. Like it is a closed figure. That's why. Now we'll discuss the concept of topology. So before that, do you have any queries from the regions that we have already touched upon? I have just some not exactly summarized, but I've just discussed the topics that the professor has discussed, so that it will be helpful for you to revise for your assignments. So if you have any questions, you can ask me. Like so far, we have discussed what GIS is. Then we have discussed the like the explanation of the definition of GIS that we have done. Then we have discussed about the GIS without computers, the cholera pandemic. I think these are all the important things that I've touched upon. Then components of GIS, obviously, the 5 components we have discussed. So before topology, if you have any questions, you can ask me. Uh, I can't. If you want to ask, please ask because I can't see uh, who has raised the hand because I'm simultaneously sharing also. That's why. Or else you can put it in the chat. I'll try to look at that. Okay, you guys are asking about these slides, no? Okay, see, once this like session is done, I'm recording the session also. So this will be uploaded, plus the slides will be uploaded, and the link I think in your NPTEL that user page, you have this problem solving session 2025. One tab is there. So in that you will get the link for this. So within a day, I'll like the after the completion of today's session, maximum by tomorrow, I'll upload both these things. So you will get the link for the same. I have more, mainly just used the information that the professor has taught, but then I thought it's better to revise so that in case you have watched the lectures long time back and you are yet to do your assignment, then this will be kind of like a recap. Yeah, Pallavi has asked. Yeah, it is possible. See, that's what I was showing you. Like Google Earth is basically a combination of all these things. Just a moment. It, one moment. I think some problem is there with my PC. One moment. Okay, it's rectified. I think. Yeah. Okay. So as Pallavi was asking, like her question was, uh, is it possible to collect the vector data on Google Earth? So the thing is, yes, Google Earth can process and display the vector data, but compared to the other GIS softwares, like which are dedicated to GIS, like QGIS or ArcGIS, it's a little difficult because there are certain file types and everything. So The supported vector formats in case of Google Earth is like the KML. I don't know if you're familiar with it. Maybe in upcoming sessions, maybe I can show you also. That is like KML file is there, KMZ file is there, and then shape files. These things I think it's better because today is the introductory session, so I don't think we should go into that much of detail. Right now, you just need to know these general things. Then maybe in the upcoming sessions, I can simultaneously show you how all these things are done in the software also. So it's better, you can understand it easily. Today, I have some issues with my computer. I don't know what happened. I was planning to show you all these things on QGIS also. I don't, so probably in the next session, I can show you whatever we are discussing simultaneously. I'll show you. So just like how I just now showed you on Google Earth, so the vector data, like I've shown you the points, which is represented as place marks that you have seen, that red one. Then lines which I drew on the road or path, and the polygon that I showed you for drawing the boundary. So yeah, that's a very simplified version, but then we have better softwares for that. Okay, so shall we discuss the concept of topology then? It's like Sir has discussed it very briefly, not in that depth. So I'll also like he has given you the essential information, so we'll do that only. So concept of topology is it describes the spatial relationships between adjacent features. So that is basically, let's say, uh, uh, like we are sitting in a classroom. So who is sitting beside you? That kind of thing. The spatial relationship. So if you have uh, if you have a polygon like this and you have another polygon like this, so sorry, this line kind of came here. One second. Yeah, we have another one like this. So what is the spatial relationship between these two features? Or maybe it might be related to a like like two polygons, a different two polygons with another polygon, or it might be related to line features or even point features. So that kind of relationship is explored in topology. Like it describes the spatial relationships between adjacent features. Topology is a collection of rules. That is the definition. So I'm just reading it out. You might have already seen it there also. So topology is a collection of rules that, coupled with a set of editing tools and techniques, enables the geodatabase to more accurately model geometric relationships. I know it's a little sophisticated. Like the simple terms, when you say is, for example, I think I have an image in the upcoming slide also, but then let's say uh, if you're not using a like topology is specifically for GIS, okay? So the thing is, if you are not using a software which has the efficiency of a GIS software and you're drawing the same thing, okay? So the problem is that it's not always possible to get the boundaries very similar. Like, if I'm drawing like this and I'm trying to draw another one like this, at times, in such softwares, when you manually do it, there is a chance that this boundary and this boundary may not overlap. Rather, you might find some kind of gap in it. Okay, in such softwares which do not have topology. So, what happens is in such cases, this line and this line will be further digitized. So you have uh, instead of a one digitized line, you will have two, and you will have a it. Sometimes the like the software will interpret it as another polygon. Like this is one polygon, this is one polygon, and this is another polygon. So there comes the idea of topology. In topology, this topology describes the spatial relationship between these two features. So where topology is used, this will be considered as one single line or a boundary which separates these two polygons. And mathematically, like this is a mathematical concept actually, which was integrated into GIS. So we, whatever features, like that's what I was saying, like you might see a, let's say a pond. We have a pond here, and then we have a patch of vegetation over here. Okay, like you have a lot of trees over here. So the spatial relationship between these two will be studied in terms of a two-dimensional plane, rather than, like, we know that these are all three-dimensional objects, but then in topology we'll consider them as two-dimensional, and then we'll understand what is the like relationship between these two. Okay. So through planar enforcement, spatial features can be represented through nodes, that is zero dimensional cells like points. That's what they're saying. Okay, I'm not able to draw it, but you have to understand this is a point. Okay, then edges, which are sometimes called arcs, like one dimensional cells like this, or polygons, which are two dimensional cells. So what is the advantage of topology? Like we are talking about topology, like why is it so important? So it provides an automated way to handle digitizing and editing errors and artifacts. Artifacts is basically the one that I had drawn and shown you. This one. This gap that you see, that is an artifact. That is essentially, it's not there. But because if in the absence of topology, when you try to draw the boundary, it's not that possible to overlap it accurately. So that kind of difficulty is there. Okay. So then in such cases, topology will account for these artifacts, and that will not come. Rather, you will get a very clean and crisp boundary. Then it will reduce data storage for polygons, because boundaries between adjacent polygons are stored only once. That's what I was saying. If you don't have this topology, then the thing is it will be stored twice, which means your data storage will be more, right? So instead of that much of data storage requirement, here it will reduce the data storage, because that boundary will be stored only once. So what I'm trying to say is, like, let's say I'll show on Google Earth again. So, okay. Huh. Here you have the boundaries, right? A little more back. Hmm. So see, you have these boundaries. So suppose I open, this is Google Earth. For example, if I open this in the, let's say in QGIS software, okay, like I open the India map shape file in the Google Earth software. So in that, you will have this attribute table. If you like can like attribute table is basically the non-spatial data. Like it will give us information about each of the states and everything, the boundaries and everything. All those data will be stored in that attribute table. So uh, if you look at that, these boundaries, for example, the boundary between this Punjab, this area, and this Haryana area, this will be stored only once in the GIS software. Okay, that's what I was trying to say. Like, this is like a lot of data is available. So, if that topology concept is not there, then this will be very difficult. So, rather, because of that, the storage and everything is well contained. So this enables advanced spatial analysis such as adjacency, connectivity, and containment. So it's like how well connected these features are, the adjacent features, all those things, and how that boundaries are controlling the feature. Those things, it accounts for that. And another important consequence is the planar enforcement is that a map that has topology contains space filling non-overlapping polygons. So you won't have any polygons that are going to overlap. You will have a well adjacent, like properly kept polygons next to each other. So this you can see, right? This is an example that was given in the lecture also. So this is an example of topological editing, and this is an example of non-topological editing. So if you take a look at this, you can see uh, this is one polygon, this is another polygon. If you have a topological editing, see these points are common to both these polygons. Okay, so you have a common boundary. So that is topological editing. Here also you can see that this 5, 6, 7, that is common. But in non-topological editing, if this was not the case, then you can see that you have an gap, a gap which was developed here, and this at times can be mm, uh, mistaken for another as another polygon. So instead of two polygons, sometimes this might be regarded as three. So uh, that is the benefit of topological editing. In general, a topological data model manages spatial relationships by representing spatial objects. Same thing that I was saying, point, line, and area features as an underlying graph of topological primitives, that is nodes, faces, and edges. The idea is, if you take a look at this, so you have A, B, and uh, okay. So let's say A, that is considered as a face, that is like a polygon kind of, that's an area, right? An area is covered. Then one, that is the like this line, that is the edge, and three is a node. Similarly, two, one, two, three, these round ones, they are nodes. The line one, then you have the line two, three, four, five. These are all edges, and then these are faces. A, B, C, D are faces. So, Sir had also discussed about spaghetti model. That is basically the non-topological model, but I'm just not like right now touching upon that. There are several models, but then we are always more interested in the polygon model, because see, topological modeling can be done for points as well as lines, but it is more challenging for the polygons. So we will focus more on the polygon model. Okay. So here you can see this is a digital map data. So you have these polygons like A, B, C, D, and then you have the nodes, you have the lines are represented by L1, L2 like that. Nodes are represented by N, and what else is there? And faces, polygons are represented by these A, B, C, D like that. So in a topological model, like if it was a non-topological model like a spaghetti model, you will not have this much of information. Like you might just have the uh, links and that nodes, like it will not give you all these kind of information. But here if you see, uh, for a polygon, let's say where is A? Yeah, A is here. It is linked to L1, this is L1 and L5. Okay, so this is L1 and L5, that is the link. And then if you mm, take a look at B, this is B, that is connected to L2, L3 and L5. Then if you look at C, that is connected to L6, like this entire thing is L6. It has internodes. So that kind of thing. And then L1, specifically if you take a look at that, so L1 has a start node as N1 and an end node as N2, and these are internodes. So all these information like polygon topology is there, the node topology is there. Like node topology, let's say if you have N1, then it is linked to L1, it is linked to L3, and it is linked to L5. So all these informations like the regarding the polygon, regarding the node, regarding the link, all these things. Link is basically the line. So all these informations are there, and then you finally have the link coordinates. So L1, if you take L1, the coordinates is 1, 0, 1, 2, 3, 4. Okay, this is 4. So 4 and 4, 4. This is 4, 4. Then 4, 10 is also there. I think this has shifted slightly. I don't know. This is 11, right? Yeah, this is also L1. This is there. So like that, coordinates have also been determined for this, each of the link. So you have idea about the polygon, you have idea about the node, and you have idea about the link. So that was regarding the topological model. Okay. So shall we move to the problem session? And I would just like to remind you one thing, like in these problems, I will not be directly discussing the problems of your week one assignment per se, and please refrain from asking me about the week one assignment questions directly. You can, if you have any queries, you can ask me, but then the thing is like these problems that I'll discuss, I hope they'll be helpful for you to solve the assignment questions, although it will not be directly whatever is asked in your assignment. Okay, so first we'll just discuss few problems from week 0, then we'll go to yeah, Tanya has some question, I think.
Yes, ma'am. Actually, ma'am, I just need to confirm it that we had got an email
Hmm.
in which two sessions have been mentioned. Like session one is like from 6 to 8, and
Huh?
session two is from 7 to 9.
Okay.
Like these both sessions are clashing. So,
No, no,
is it
yeah.
necessary for us to join both of the sessions or just one?
No, no, both of the sessions, like we will be, like me and the other teaching assistant, both of us are basically going to discuss these topics and the problems. I'm not sure it will be exactly same, but then the idea is more or less similar. So the 6 to 8 and 7 to 9 they've kept for the convenience of the people. Like if you guys are available from some people can join at 6 to 8, so then they can join like that, or some people if they can join from 7 to 9 that way. It's okay. Like you can join either of the session,
Oh,
that doesn't matter.
okay, ma'am. And the ma'am, second query is that even in the email, the thing was mentioned that we that about things about weekly assignment would be carried, like not basically about answers scripts, but
Huh?
basically like how many of the pages are the how many pages or word limits or what kind of basically a way in which we can like come up with the assignments,
No, no, weekly assignment,
like
like
where
if
we
you
need
have
to
seen on
submit
the
and
okay. See, in that NPTEL portal, if you see, that is like MCQ kind of questions, right? Assignment. So I don't think you have this word limit
just I was
requirement.
checking.
Yeah, yeah. So it's just like you have to enter the answers and submit it, and then later on they will also show the answer key. Like once that submission date is done and evaluation is done, by default the answer key will also come.
Oh,
Okay.
thank you, ma'am.
Okay. Okay. Thank you. So now we'll go to the problems part. I hope. Mm. Okay. So please participate and give me the answers. So which among the following is India's regional navigation system? This is from your week 0. We have GPS, GLONASS, Compass, and IRNSS. Yeah, the answer is D, IRNSS, that is Indian Regional Navigation System. But then, as of now, we call it as NAVIC. Okay, so good. Answer is IRNSS. The next question is, which of the following is not a component of GIS? You have 5 components. Yeah, the answer is satellite. So, what are the like 5 components? Can you just put it in the chat if you remember? Like we already have software, data, and people. What are the other two? Yeah, hardware is there. Yeah, method. So we have software, data, people, hardware, and method. Okay, satellite is basically not considered as a component of GIS. Okay, good. The answer is satellite. The simplified representation of reality is called, what does GIS do? Yeah, yes, the answer is A, model. So you get a very simplified version of the reality. Major differences between vector and raster data models. Vector and raster are same data models. Vector is continuous, whereas raster data model is discrete. Vector and raster both are discrete. Vector is discrete, whereas raster data model is continuous. Yeah. So the answer is vector is discrete, whereas raster data model is continuous. Yeah, you guys are right. So it's basically vector data it represents precise locations and boundaries of features using point, lines, and polygons, like we discussed. And features have clearly defined shapes and boundaries. So therefore, vector data is more, best for well-defined objects like roads, buildings, political boundaries, like something which has a well-defined, mm, you know, uh, feature. In such cases, we will use the uh, vector data. Okay. And for raster data, it represents spatial information as a grid of cells, pixels. Like if you look at the photograph, it like, for example, you have taken a photograph, okay, and you zoom in. Like there is a limit to which you can zoom, and then at one point it will look very pixelated. So that is what a raster data is. So it stores information as a grid of cells or pixels, where each cell stores a value. Each cell has a particular value. So that will only show a smooth variation with no distinct boundaries. You don't have any proper boundaries in case of a raster data. It's more or less continuous, and therefore it is best for gradual changes over space, like terrain, climate, land cover. Like if you are familiar with the idea of land use, land cover, then you will know, like land use land cover department, what they do is they will assess a place, like historical data they will take into consideration, and they will see, and then they can predict how things are going to be in the future. So that kind of work, for that you require the raster data. So that is the difference. That's why we are saying vector is discrete and raster is continuous. In GIS, topology is implemented through data storage, raster model, structure, collection. Anybody else? Like, I've got one answer. Okay. So, yeah, so the answer is right. It is structure. So, GIS implements topology through data structures like the arc node model and topological rules, ensuring that spatial relationships like connectivity, adjacency, and containment are correctly maintained. This improves data accuracy, analysis, and uh, editing efficiency in GIS applications. Okay. Which of the following are true? You have four statements. So just let me know which do you think is true. What is digitizing? That is basically the question. Yes, you guys are right. The answer is digitizing involves tracing map features into a computer. Okay. So yeah, you guys are right. So if you remember, like I don't know if you guys have seen, like we get uh, these map what do you call it as atlas books are there, no, which contains the world map, the country maps and all those things. So when you digitize it and you know put it into the computer, you can actually uh, see the locations, like proper locations and everything, which it's not possible in a book. So that's basically the benefit of digitizing the map features into the computer. Spatial referencing is the process of which of the following? You have four options. Go through it and please let me know the answer. What is spatial referencing? Not really. Like, I understand why you guys are saying that. Yeah, the answer is combing attribute values with locational information. Spatial referencing is like you're giving the location uh, information to the attribute values. So attribute values is what? The non-spatial data. So for the non-spatial data, you need to know what uh, it, to which location is it associated with. So that is done by spatial referencing. So the answer is A, which is combing attribute values with locational information. So that is all with the questions that I have. So if you guys have any other questions, you can ask me, or I'll just uh, briefly summarize what all things we have discussed today.
Um, Good evening, ma'am. Ma'am, there is a
Good evening.
question about if I need to monitor landslide,
Huh?
then what should I use? A vector data or raster data?
You will sort of use a combination, but then mostly you will use a vector data. Like you for that actually you also require the DEM model, digital elevation model. I
Elevation
think
model.
yeah. So yeah, you will use a combination. Like you can monitor the region using the raster data, but then for further interpretation you will require the vector data.
Okay.
That is
Okay.
as
Thank
far
you, ma'am.
as I know. But yeah, if I can get some more details on that, maybe I'll discuss it in the upcoming session also if you want.
Oh, yes, sir. Yes, ma'am.
Mm.
Okay. Thank you.
And of course, like you guys can ask me anything related, like if you want me to discuss any specific topic related to GIS, you can just put it in the chat so that if not in the same session, I can do it for you people in the upcoming sessions. So you can feel free to ask me anything, like don't hesitate. It need not be especially like sticking on to the things that have been discussed or to your assignments. If you have any other things, you can just put it in the chat. I can discuss that also. Okay, so I'll just briefly just rush through the slides and just refresh what all things we have discussed today. So we have discussed what is GIS. We have discussed its definition. Then we also discussed about GNSS. I specifically took this because I'm not sure who asked, but somebody had asked about this in the forum. That's why I just kept this here. Then examples of GNSS, why it is like where it is used, what is its uh, you know example that we have discussed, the slight difference between GIS, GNSS, and remote sensing, or GNSS or GPS. Like GPS is more familiar to everyone, that's why. But then as a whole, you call it as GNSS. Then GIS without computers, we have an example of the cholera epidemic. Then how GIS can represent a simplified world, then stages in the GIS project, what all things are involved, the components of GIS, and we discussed what all the components are. Then we also discussed the different types of GIS data, the spatial data and the non-spatial data, or and then in spatial data itself, we have the vector data, the raster data, the TIN data, that is the triangulated irregular network data, which is mostly for 3D purpose. Then we have the vector data, in that we discussed about points, lines, and polygons. And then we discussed about the nodes, internodes, begin node, end node, all those things. Then the concept of topology, advantages of topology, then the difference between topological editing and the non-topological editing, then the data model and the topological model. And then we have discussed the problems. So, see, this is your first session with me. So, if you have any suggestions, like somebody has asked a question. Yeah, just a moment. I'm not able to open the chat. See, the vector data is like I was telling you about the shapefile, right? Uh, that shapefile is basically, it can be a point shapefile, it can be a line feature shapefile, it can be a polygon feature shapefile. So you can actually, I think if you uh, Google it also, I think you can get it. In fact, in these databases itself, at times it might be there in QGIS or ArcGIS. So I think I have, for my study purpose, I have used this USGS Explorer, Earth Explorer. So you can get from that. But I think more or less everything, if you just Google it, like you have to be specific. Like for my work, I needed the India shapefile, India map shapefile. So at times, what happens is you just need the outline and not the specific district or state boundaries. So accordingly, you can just search and find it. I think it's available. Like most of the data is freely available. There are certain things for which you require permission. So as I was saying, like if you guys have any suggestion, like how you want this session to be, like the idea of this session is that it helps you to do the problems, the assignments easily, and also if there are certain topics that you heard in the lecture and you're not very clear about, then for that purpose also. So if not now, if you have any suggestions or if you have any questions from the upcoming lectures, upcoming week lectures, then I would suggest that you can either directly put it in the forum, like you can ask that in the forum, or I'll do one thing. I'll put my just a moment. I will put my email ID here. So if you have any questions related to this topic, or you have any suggestions like how you want this to be, then just mail me or put it in the forum. Okay. So that is it for today's session. I hope it was helpful for you. If there is any ground for improvement, you can just let me know. If you have any queries, you can ask me, or if not, you can uh, leave the meeting. Thank you so much for listening patiently. I hope it was not that boring. Monish, see, these both sessions, the purpose is the same. So it's basically spaced like that so that if some people are not able to join at the 6 p.m. session, then they can join for the 7 p.m. session. Like both of us are basically trying, like the purpose is same. So you don't have to worry. Whichever is convenient for you, you can join that. Yeah, you will get the slides. Like I'll try my best to maximum upload this by today or tomorrow. See, you have this in your Swayam NPTEL portal. You have this part where they have given problem solving session 2025. So there, I think they'll provide you a link where you can find the link for these slides. Uh, yeah, okay. Who was? Okay. Jacob Gang. Yeah, you were asking like Google Earth Engine as a okay, is Google Earth Engine a GIS software? It's not a full-fledged GIS software. Like it has certain GIS tools and all, but it is mainly like a what do you say? It's a visualization tool, not exactly a GIS software. So you can't completely call it as a GIS software, but yeah, it gives you the certain aspects of the GIS. It's a little more user-friendly, you can say. You cannot do more of the spatial analysis that you can do in the ArcGIS or QGIS or like other full-fledged GIS software. Like you can do a lot of things. That kind of work you cannot do in Google Earth.